Hi, welcome to the third video of Week 2 of the Protocol of Creation program, Structural Arrangements. Let me start by saying that any formulation of the criteria by which the merit of a structure could be judged is inevitably controversial. However, most people would agree that bamboo structural design's principal objective is to provide an efficient solution with maximum economy of means. There is no consensus on the proper manner to classify structures. However, Angus J. MacDonald, in his book Structure and Architecture, explains that the more critical factor in determining the level of efficiency of a structure is to categorize it into one of the primary categorization: form-active, semi-form-active, and non-form-active structures.
Number 1. The non-form-active bamboo structures.
The non-form structures are post and beam structures in which a series of horizontal elements are supported on the vertical axis. There are two kinds of non-form structures: the load-bearing wall structure and the frame structure. The load-bearing wall structure carries the floors and roof weights, usually positioned parallel to one another at approximately equally spaced. However, irregular plan forms are possible. One typical example is the social housing of Colombia using the traditional technique Bajareque. On the other hand, the frame's principal characteristic is that it is a skeletal structure consisting of beams and columns. The total column occupied by the structure is less than with load-bearing walls, and individual elements carry larger areas with greater amounts of internal force.
Number 2. The semi-form active bamboo structures.
The semi-form structures contain the full range of internal force types: axial, thrust, bending moment, and shear force. This type of structure achieves greater efficiency than a post and beam structure but less than the form-active structure. It can be adopted because the shape of the building is such that neither a simple post and beam nor a highly efficient form-active structure solves the equilibrium problem.
Number 3. The full-form active bamboo structures.
The full-form active structures usually are applied when a large span is involved or a high degree of structural requirement exists. They have geometries that are more complicated than non-form active and semi-form active structures that produce distinctive shapes of buildings. There are two kinds of form-active structures: the compressive and the tensile. The tensile form-active structure is the more efficient kind of active structures. As the tensile strength of bamboo is 3 times greater than its compressive strength, this kind of active structure makes the more efficient use of bamboo's natural characteristics. The compressive form-active structure have a very complex geometry, making it difficult to determine accurately and thus difficult to reproduce exactly in a real structure because the radius of curvature of the surface is not constant. Unlike the tensile form-active version, the compressive form-active structures must be rigid, and its geometry does not change intentionally. The efficiency of these structures depends on the computational analysis using techniques such as the finite element analysis. When a project cannot apply expensive computational techniques, the so-called translational forms can solve the problem because it is close to the form-active shape but has much simpler geometry. The hyperbolic paraboloid and the elliptical paraboloid are examples of translational forms, which can be generated by simple curves such as parabolas or ellipses made out of straight elements. As you see, the ability to place a structure within the appropriate category forms a useful basis for assessing its performance and the appropriateness of its selection for a particular application. An aspect of the relationship between structure and architecture is the possibility that the features associated with structural efficiency can be used as the basis of a visual vocabulary that conveys architectural meaning. The measure of a good structure is not that the highest level of structural efficiency has been achieved, but that appropriate level has been achieved. Below this video you will find McDonald's book, Structures and Architecture. In any case, the bridge is the maximum expression of the bearing capacity of the bamboo. Structurally speaking, if you can build a bridge, you can build anything. So here is a brief introduction of how to build a bamboo bridge truss. First, you have to determine the structural design through model making. One bridge is made from 2 trusses. Domain the construction technique in smaller scale for economic means. Second, install a Cartesian plane to create a grid to translate exact measures from small scale to real size scale. The Cartesian plane can be made out of metallic scaffolding because it is easy and fast to install and uninstall. Number 3. Attach vertical tubes to the scaffolding to help bamboo to bend according to the required curve. Number 4. Horizontal unions. Usually, bamboos are sold in pieces of 6 meters long. To make longer elements, you must introduce a slender diameter of bamboo or wood to link both extremes. Number 5. Once finished, lift it up. Now you can compare it with the scale model. Of course, you may have questions. Prepare them for our next live session. Also, below this video you will find a private collection of the construction process of this bamboo truss test built in the Chongqing Jiadong University. Most of the bridge designs are symmetrical because of the reciprocity between both extremes. The same principle can be applied to non-bridge structures. For example, the case study of the Lavender Bamboo Southgate project in Shandong, China. First, let's define symmetry. 2 common definitions are: Number 1. The quality of being made up of exactly similar parts facing each other or around an axis. And number 2. The correct proportion or correspondence of the parts of a thing. So, how to use symmetry for an asymmetric site in 3 steps.
Step number 1.
Find midpoints and connect the extremes. This first axis will be the original reference to generate symmetry within asymmetry.
Step number 2.
Draw a perpendicular axis to create a centroid. The centroid is the desired point where to place the center of the structure.
Step number 3.
With the centroid defined, place the structure. Now the structure can be tailored accordingly to the desired program. Symmetry is the main organizer of architecture in any part of the world. To use it, one must study the classics. Final though from Simon Belles.
Symmetry potentiates the good and potentiates the bad of architecture. Where there are proportions, the symmetry works very well. But when there is symmetry and there are no proportions, the ugliest buildings in the world are symmetrical.
To wrap up this video, let's take a minute to discuss the exercise of week 2, manipulating the structural arrangements. This is the time to get into some trouble and make some warm-up bamboo models. This is not about making perfect or beautiful structures. The objective is to make an incomplete exercise to produce experience on what it takes to build each one of the structural arrangements. Don't try to make a project out of it or to solve anything at all. Focus solely in representing as simple as possible the type of structural arrangement in turn, and don't mind about the scale either.
How to deliver the exercise.
Make 1 sketch model per arrangement 5 to 10 minutes each. 1 non-active structure, 1 semi-active structure, 1 full active structure, and 1 hyperbolic structure. Intentionally, I'm not going to tell you how to make them. The idea is to stimulate that part by yourself. Then, in our live session we will work together on that. Go to the group discussion and upload 1 picture per sketch model with a comment about the strengths and limitations you found on it. During our next live session we will review what you did and we will make an exercise together. Bring your materials. If you have any question, you can post it in the group discussion of our platform. Thanks for watching the 3rd video of week 2 about structural arrangements. Don't forget to download the resources below this video. We are about to cross to week 3, defining the intentions of your project. Until then, take care.